like 1.5 or 2, and except on really fuzzy, really thick grass where it might pile up a little bit more. So it's worth keeping those things in mind too, especially for me. I don't want to be disappointed and wake up and see that nothing's accumulating on my driveway. Well, of course it's not accumulating in your driveway, you idiot. It's got to get about 6 inches of snow first before you can coat that. So I have to keep myself ready.
But
So,
is it better, like, for warning people for travel to be like, if people hear, oh, it's going to accumulate 1 inch, they might think it's only going to snow for an hour or something, and
that's
not
a great question.
pay attention as much.
Yeah.
It's going to be snowing heavily for a long time. Just
Right.
don't know.
Right, I don't know, that's a good question. And maybe there's buried underneath that is, what happens to the operation of motor vehicles for the average person when it's snowing intensely? Is it really that you slide, or you just get nervous? You just lose visibility, and on top of that, you just get nervous. And maybe you're prone to simple mistakes that don't involve actually treachery in the conditions, but just you're not on your game. So I wonder about that. Those are really good questions.
Another item worth noting is we talked about the April records for like latest day, have a temperature at 19 or below. And you, Carl, just pulled up the records.
Oh, what is it?
The latest day we've had a temperature of 19 or colder in April was April 23rd. So we might challenge that.
Wow, that's pretty awesome.
Yeah.
That's pretty awesome. So we got a lot riding on this thing. It could be the trifecta tomorrow. We could have a whole bunch of different things coming in, which will be fun. Okay, so we're going to have, despite the exciting weather, we're going to have a slightly abbreviated discussion, only insofar as we won't do as much with the current ops, and we'll talk a little bit more about the forecast. So I'll do a fairly brief look at the current observations. We'll start at the 500 millibar map, if we could be. And we'll not worry about the western part of the United States and off the coast today. There isn't too much happening anyway. So here's our 500 millibar map from this morning. This looks like a wintertime weather. We've got the sort of Hudson Bay low, which is fairly intense, sitting a little further north than it might in January, but on the southern periphery of the archipelago, temperatures are in the -40 range at its core, so that's pretty cold. Not as cold as you get in the depth of the winter, but it's really not another category. Strong northwesterly flow into a negatively tilted trough with a fairly sharp curvature maxima down over the Kentucky-Tennessee border, and then a slight diffluence, and then a downstream ridge that's not as pronounced as sometimes you get, but it's not zero. And so in between here and here, there's a lot of ascent, enforcing for ascent in this location over the middle Atlantic states, and that's where we see the circulation in the satellite view, and we'll see it in the radar as well. A broad ridge over the western 2/3 of the country, kind of a flat ridge, but we're just downstream of its axis, if you want to call that's what it is. And of course, we're experiencing a beautiful day here. Low dew points, crystal clear skies, what early April often feels like around here, not particularly late April. A little bit of a chill in the air, I think everybody would agree. And then this just wimpy little trough along the Oregon-Washington coast is really the feature of interest for our weather. It's not this though, which turns into its own really intense upper feature over the next couple of days, but it's this little wimpy trough, which if the forecast panels I looked at today, which were the 6Z run, are still going to bear out at 12Z, this thing kind of disappears a little bit between now and about 24 hours from now, and then it kind of revs itself back up, turns into a really intense little, but very small scale upper vortex and slides across central Iowa, just south of the Illinois-Wisconsin border during the day tomorrow into tomorrow evening. And it's perfect setup for us to get to remain on the north side of what's going to be a pretty chilly system. So there's a whole bunch of interesting things going on here. This is what I want to point out. This is, don't forget the Cordillera is like that. And so this flow is pretty much across the high terrain at high latitude, especially, from Idaho all the way into Canada. And so if we go to 700 millibars, let's see what it looks like there. And you just begin to see this little bit of a lee side trough. So here's the warm anomaly in the isotherms, coincident with the pressure trough in the geopotential height. So and it's a high latitude lee side trough. This is not the most uncommon thing you ever see, but nonetheless, it's definitely got that whatever's evolving here in western Montana has a lee side origin. And it's not so well put together right now. Let's see what it looks like at 850. At 850, it's even, it's so hard to tell what's going on in terms of the temperature field. So 700 might have been the best level, but one gets the impression that there's geopotential minima, so much as you can make sense of them at a couple of stations in Montana, sitting right in the apex of that. Let's go back to 700 feet if we could. Right in the apex of that nascent lee side trough immediately in the lee of the Montana-Idaho Rockies. So that's really interesting. That sets up a barochronicity on the northwesterly flow side.
You can even see that, I'm sorry, you can even see the frontogenesis that's already started, like it's.
Right in here.
Yeah, right in there, yeah.
So you've got this, you don't make a mistake with the rapid city wind of 30 knots from the southwest. That's a real wind. You can bet that's right. And then you've got these northwesterly winds in Aberdeen and in North Dakota. That's 90-degree wind shift with 10 degrees of temperature contrast across that. So that's strong horizontal frontogenesis already in the lower to mid troposphere. We don't see that at 500. We could revisit that over the Dakotas.
Nice confluence there.
So here's the Dakotas at 500. Weak confluence, it's not zero, and broad horizontal temperature contrast.
It looked like we lost the op
At Rapid City,
at City.
or something went wrong there. Maybe it's, I don't know where it is. So it's, looks to me, this was one of the things I was gonna say about this storm. We'll see it in the VIS 5B from a GFS 06Z simulation. Looks to me that this thing's controlled in the lower troposphere by and large at its initial genesis stage. And that seems to conform to what we're seeing in these observations here as well. And I think just for completeness, if we could go to 300 millivolts peak, interrogate the jet is weak too. So the strong jet is off the Pacific Northwest coast with that much more intense feature. We'll see that in this 5B, the more intense feature as well there. And then here we're looking at a pretty modest 300 millivolt jet, 112 knots on the border near the Red River of the North. That's not really that impressive. None of the ops go over 100 knots, as far as I can see. They're all 90 or something. And so a few of them, in the analysis, go over 100, but none in the actual observation. So that's a weak northwesterly flow. Discernibly a jet feature though, and on the western side of the cyclone, the upper trough, I mean. And then if you wanted to have some sort of ascent in addition to the lee side stretching, you're in a decent position for that, but I bet it's going to be fairly weak. So that's the broad picture of the genesis region for what comes at us next. And I think maybe I'll just step through the VIS 5D that I have. Some of that, Michael, will be what you say in the forecast too, but I won't try to do too much overlap on that. So here's the 500 millibar map from 6Z. Let's go ahead a couple of clicks to 12Z just so we see what we're looking at the same time. So this is what we just looked at. Here's the trough off the west coast. Here's the trough over the Tennessee, Kentucky region in the downstream ridge. So it's a pretty decent looking upper wave and a complex for production of vertical motion there. Let's put the theta on top at 2 degree increments instead of the 5 that we just saw on the other map. So you can see a pretty intense upper tropospheric barochronic zone at the base of this trough, and it's characterized by cold convection. That's an intensifying upper frontal feature. There's confluence over the central part of the Great Lakes and the Upper Peninsula that's going to produce sort of a warm frontal barochronicity on that northwestern side of the storm. But here where we see our upper trough, we even at 500 millibars see a little bit of a thermal ridge over the high terrain. And so this trough is slightly ahead of the thermal trough to its west. But that's okay because it's going to produce cold advection on its front side and warm advection over in the broad ridge, at least into the Dakotas. So there's a very interesting thermal pattern that's evolving here throughout the middle and upper troposphere that is probably going to have something to say about the way this structure takes shape. So can we go ahead a couple of clicks? We'll go to 18Z. And we see here again, this is this little bit of a thermal ridge, I think, that may have had its origin in the lee of the high terrain. And as I mentioned before, I don't know if it's true in the 12Z analysis, but the upper trough seems to disappear a little bit. It's just a weaker feature at 6 hours into the forecast. And one begins to wonder, what's really going to happen here? Except that there's more or less zero geostrophic temperature advection here, and then there's pretty decent warm advection across South Dakota. So that even at 500 millibars, there's some decent horizontal temperature advection.
John, I was going to say for that upper trough, I think part of why it gets lost, I mean, the vorticity field, it certainly gets very muddled. But I think in the PV field, you can actually follow along pretty well.
Oh, yeah, I have the PV surface. I'm not looking at just an ISO, I'm looking at an ISO surface, so you can see it in shade. You're right, I did notice that. I only looked at it just before the discussion. Good point. So let's go 6 more hours ahead. This will get us to Saturday. It seems to me the thermal ridge aspect of this developing structure is the thing that's really beginning to take a decent shape. So you have strong cold advection immediately behind a region of decent warm advection, even in the middle troposphere over the plains. And that's a nice thermal advection field to stop developing a cyclone. So let's keep on doing the same thing and see what we find going on. This is 06Z Saturday, very intense barochronicity, seemingly getting itself oriented and in phase a little bit better with the upper trough as it emerges out of the high terrain. Keep on going, Pete. Then I think it looks really much better by about midday Saturday. We get this really decent cold advection region right at the leading edge of the upper trough, and then substantially less, but not zero, warm advection. It's stronger at lower tropospheric levels over northern Illinois, central Iowa, and northern Indiana. So things are really starting to shape up in terms of the phasing of the thermal wave and the upper wave. And let's go 6 more hours. I think you see that continues, though the wave, again, having a hard time staying strong. This one's really robust, but it's not our interest. And then the last one, we'll get to a cross-section at this time. Right here is perfect. So I wanted to take a cross-section, I think put theta on there. Yeah, this is the time, I think this is the time. So this is right through Madison, in the middle of the cross-section, and it's right through a pretty strong barophilic region at 500 millivolts. We can tilt this up.
You want to look at it from the east to the west?
From the east, please. So that's a pretty intense, this is theta, don't forget dry theta. That's a pretty intense frontal zone. You've got something at the surface on the order of about 10 or so degrees, these are every 3, 10 or 11 degrees C across that thing, right at the surface. And so one of the things that's intriguing about doing that is let's see how frontogenetic it is. And this is just the horizontal frontogenesis function. And so here's that intense band that we were talking about earlier, Mike, with about 850. That's where the really intense frontogenesis is in the lower troposphere. But it's not without pier above that. All the way, this is at 5.2 kilometers. This is more like 7 or 8 kilometers. So it's a deep frontogenetic layer right along the front edge of that front. It's really strong right at the surface. And then let's put on vertical motion. And we're looking just at updraft. So that's every 0.2, so 2 centimeters per second. So pretty intense updraft all the way through the column, most intense in the lower troposphere, and of course on the warm side of the upper frontogenesis axis, or the whole vertical frontogenesis axis. So it's a really nice picture of what's going on in the forecast anyway, to drive the ascent that's going to be occurring right over us at 0Z tomorrow, if this forecast bears out. I wanted to look also at theta E. And we'll take theta off because it gets a little confusing. And take some of these other things off too. We take the frontogenesis off as well. So this is what the theta E structure looks like. Here's the surface front, which in theta was not quite as intense, but that's always the case. 309 Kelvin theta E is right here. And what I did is I initialized a few trajectories at this time. One of them right near the peak of the slope of that surface, one a little further down and one further down still. So if we can go to trajectory, and then we got 4, 6, and 8. Yeah, so here's the one that I initiated near the peak. Here's one a little bit later, and here's one another little bit later in time, all along the 309 Kelvin theta E surface, which is very steeply sloped right here in the front edge. It's also convectively unstable in the layer right ahead of the front, so there's a chance maybe for some thunder and lightning if that can be realized. So let's step backwards in time and see where this air came from. It grows rapidly. Right there is good. And then let's take a top view. Okay, and we'll get rid of everything else that's on here, including the cross sections. That's not particularly helpful. And then maybe we'll get a top view, a side view, just to give one more click ahead because this thing starts to rise at the next time. This green. Yeah, I want to see what's going on here. Okay, so let's now go back to a top view. And let's put theta and horizontal frontogenesis on there. And let's make sure we're at the right level. So we got to tilt it back up again. Sorry, we keep doing this the wrong way. And let's drag both of those levels down to right about there. That way we know we're talking about what's happening to this collection of air parcels. Okay, let's take a top view of that. So this is the first of a series of ascending air parcels, and they all end up kind of ascending the same theta E surface. But this one is doing so right at the warm edge of this intensifying baroclinic zone, which is at, I forget what height it is, it's about 3 kilometers or something like that, 700 millibars. And this is the horizontal frontogenesis axis. very intense. So we've been tracking that without calculating it all the way through this discussion. So this is a really intense horizontal frontogenesis axis along the warm frontal portion of the baroclonicity. And that's driving strong ascent here at Omaha, well, north of Omaha along the river. So let's see what happens, flip it around again. Let's click another time. What were we at? Can we just see that height first before I?
You're about 1.9.
Okay, 1.9, so it's more like 70 millivolts or something. Look at that. That ascents just in 3 hours. Let's go to the next, move these things up to that peak.
You want to do that?
Yeah, let's do one at a time. Perfect. And that's 3.3 kilometers. Let's see what that looks like. These things have not yet found that level. So it's still in the same relative position. It's on the warm edge of this kind of warm frontal portion of the baroclinic zone, and that's strongly frontogenetically active. There's the axis. You want to be on the warm side to get the air to rise. And then we'll go one more time with that air parcel trajectory. But we have to see where it is.
About 5 kilometers.
Yeah, about, okay, so 5 kilometers. And you can see that the higher you go, the weaker the frontogenesis becomes. So this is driven by what's going on in the lower troposphere, in my opinion. And you're also kind of, you're still on the warm side of a broad baroclinic zone. It's hard to tell whether or not it's the warm frontal or cold frontal portion of it. Lower down, it's obvious that you're on the eastern flank of the thermal ridge that's produced by the low-level subsidence that produces the least trough. Up here, it's not so obvious. And then I think we're going to start to see these same two these other air parcels that have been confined to the return flow in the lower troposphere finally start to feel the effect of the lower tropospheric baroclinic zone. So let's see if that's true. They do the same thing. Yeah, they're starting to rise. So we'll forget about the green one for now. They'll leave it on there, please. And yeah, how about the purple one or whatever it is? What is that color? Wauve?
Kind of a magenta.
Oh, magenta. I don't know what it is.
Sure, there's a
I'm
wedding
not
dress.
colorblind. I'm just color disinterested. I don't.
Sure, there's a wedding dress color that accurately describes what color that is.
So look at this. Now, don't forget, this is the air parcel that's now ascending. And it's at about 3.5, I think, kilometers. Is that right, Pete? 3.7?
Yeah.
So it's further along that theta E surface. And it has the same basic characteristic. It's on the warm edge of the evolving baroclinic zone. It's also on the warm edge of the axis of frontogenesis. This one will also start to behave in a similar way. So one of the things that this is starting to point out to me as I looked at it this morning was we might not get the greatest ascent as the storm comes by us, but we're going to get the most consistent ascent, I think, because it's more than one air parcel that makes its way up the escalator. So let's go to one more time here, and then I'll be done. Same type of analysis. So the blue is now starting to climb the same thing. And I think let's go down and see what that one's doing. Yeah. That's 2.5 kilometers-ish.
Yeah.
725 millivolts. And so, same exact basic structure. Warm side of the baroclinic zone, axis of frontogenesis. It's just getting itself into that environment, and it's being driven aloft. And this is these two are the ones that are actually affecting the precipitation rate, probably in Dane County. So anyway, that's what it looks like to me. The higher you go, the weaker the signal for forcing of the ascent gets. There's not really any obvious upper trophy forcing for the ascent. It's mostly controlled by lower tropospheric frontogenesis, which I think is given an early assist by producing a baroclinic zone on the eastern side of the subsidence warm bubble. So it's a really interesting storm. It might be a characteristic of these kinds of storms. That is high plains weather events in the cold season. This is an oddball being so late in the season. So I don't want to say any more because I know you've got other things to say, my friend.
So, is this the last more than an inch snow you think this year?
Not this year. I'll say.
Yeah.
Snow season, I'm sorry.
Yeah, you got to be careful with him. Yeah. I was about to say yes.
I'm not gonna fall for that. Okay, so first I'd like to go to pivotal and then we'll go to tropical tidbits. Look at a couple of different features. I concur almost entirely with John that this looks like it's gonna be largely driven, at least our snowfall, from processes going in the lower troposphere, frontogenesis. But I think the role of the upper trough is one not to be discounted, because I think it does play a minor role in at least helping to focus where some of that ascent is, as well as driving some of the initial development of the surface cycle. But it's not, the interaction between those two really have to do a lot more in-depth study to get a sense of how strongly it's forcing the ascent. So the first thing I'd like to look at, first of all, you can see the winter storm watches that have been issued. Again, just seeing this map on the end of April is amazing. I'd love to see it in the middle of January as well, but anyway.
Yeah, sure.
You would?
And let's go to dynamics.
Everybody knows that.
It's let's go to the 2P, actually, I'm sorry, we're gonna go to vorticity at 500 millibars first. Notice, again, consistent with what John was saying, look how messy this is, right? We have this broad feature, vorticity maxima. You can look, if you look really carefully, you can see that there is a local minimum in the geopotential height field, right? You can see the trough there. So the vorticity field is fairly disorganized. If you go back a couple clicks to the analysis time, okay, there's where the trough just making it into the northwestern United States. So let's go to 12 hours in the forecast. As it sort of crosses the Rocky Mountains. And while you do see some enhancement in the vorticity, you're kind of thinking this trough is falling apart. This looks very disorganized, even more disorganized than it looked earlier. Some of this is the hydrostatic interpolation of the height field over the mountains, but you're just really losing the structure of this. It might also be some gravity wave contamination in the actual calculation of winds and heights, but that's pretty messy. And then if we go forward again to 18 hours, which is going 6-hour chunks, things beginning to sort of level off. You can now begin to sort of recover some of that trough-like feature as it moves away from the Rocky Mountains, but still not the most coherent, most exciting thing. If you'll show me this map that says we're going to get several inches of snow within 12 to 24 hours of it, I would look at you and think you're crazy. I don't think that doesn't speak to me, snow event or snowstorm. Go to 24 hours.
What was that word?
I'm gonna jinx the whole thing in a few
Oh, all
moments.
right.
And then by this time, now we have something that looks both potent and important as it moves into northern Nebraska. A really nice vorticity maxima has emerged in this flow. This, by the way, is our next snow threat for early next week, but we won't talk about that. This feature right here, at least for the northern part of the state. But here's our nice vorticity maxima, down some ridging downstream of it. So as you have that change in curvature, that's a nice area to at least begin having significant ascent occurring. That's probably where your first set of trajectories.
Yeah, that's where the green line's coming up, yeah.
Okay, we go ahead to 30 hours for the forecast. And even better, nice curvature associated with this. And where you go from that anticyclonic curve to cyclonic curve, you go through the trough. And looks like the edge of this as it moves into northeastern Iowa, this is 18th tomorrow, early afternoon, is going to be just to our southwest during this time period. But we're probably already we certainly already into the snow at this point. Let's go ahead 3 hours.
Look at those three spokes. It almost looks like the three fates of old.
Looks like it's a badger paw or something. But there it is. Again, really nice looking, or better looking upper trough than it did at earlier times. As you can see, it begins to wind through here. This is again 21Z, so 4 o'clock in the afternoon. Trough axis is still northwest, so we're still going to be getting precipitation at this point. Let's look at some other fields, certainly. And then one more, let's go to a few more. 36 hours.
Negative vorticity there in between?
Yeah.
And here, in this region, this is getting, it's maybe inertially unstable, so that could also
It'd be recent.
contribute to heavy precip, and maybe there could be south of us some thunder and lightning.
Yeah, because there was that convective instability in the cross section.
You bring that up into the updraft, you can certainly get some significant vertical motion. And so this is now 0Z, and the trough is just, things are about to shut down once this trough axis goes by. But again, from that really messy feature to something that's much more consolidated, we're going to look at that on the dynamical tropopause in just a moment. So let's go to 39 hours, I think this is going to be the end time. Not the end times, but the end time of the storm. With the trough axis now biased, and we're now in a region of presumably subsidence that's beginning to occur as this now shifts to Michigan. So if we go back and look at the dynamical tropopause, so we're going to look at the 2 PPU surface right there. And we'll go back to 6 hours in the forecast. Here's this trough. Now this feature, decent curvature, everything you'd like to see with an upper trough, that's something that looks pretty significant. Let's go to 12 hours in the forecast. Again, this really maintains itself. And another interesting aspect of it, which wasn't really clear in the early maps, is you can also see, I guess, upstream of it, this tight thermal gradient along with dynamic tropopause, or potential temperature gradient, which I guess is some vestiges of an upper front, although it doesn't, it's gonna last too long with difluent flow here, probably ripping this apart. But that looks pretty well developed. Go to 18 hours in the forecast. Even better.
Yeah.
Right. So this is a feature that while in the vorticity field, this is for those of you with 311, we talked about potential vorticity and vorticity. Here's a feature crossing over the mountains that look really disorganized in the vorticity field, but in the potential vorticity field, it's consistently a really nice feature. You can track it. PV is conserved. There's not much in the way of diabatic or frictional processes involved with it. This looks like a pretty decent upper trough.
Not because of the phase of temperature and winds and graduate?
I think so, yeah, the gravity waves are effectively filtered out of this, so it's not gonna get contaminated by that, in the vorticity, but yeah, the potential temperature, the stratification, the vorticity, that product of those two gives us a nice PV, and we're looking at not PV itself, but potential temperature along the PV surface, and so it really shows up extremely well. We go to 24 hours, start time of our snowfall, you can see it even beginning to take on a nice tilt to it as well.
Feature.
So this is a really, going to be a really interesting feature. I'd like to switch this view. I don't know if we have it available for the NAM. And I don't want to pick your favorite forecast. Okay, in the NAM, you can see there's the vorticity structure with this. We don't have a PV map with it, but you can see a really nice upper trough. But I wanted to follow through with this because I think this gives us a couple of interesting factors, features in it. Let's go first to the surface temperature the pseudo-reflectivity. So this is near the start time of the event. The NAM has us at 12:00 tomorrow morning, so 7 a.m. Light rain just beginning to arrive in Dane County, maybe not quite the best yet, 999 low, broad area of snowfall, and the darker this is, the heavier precipitation rate. Let's do a sounding on Madison at 12:00. One of the factors that John mentioned was that we have dry air in place over us that's being infected into our area. Tomorrow morning, we're going to start off warm. We're going to say, well, this is not going to be a snow day. We'll probably get up to 60 like we did today, or at least maybe down to mid-50s if we had sun. But you notice this sort of onion-shaped profile, whatever, in the lower troposphere. It's saturated above, but we have this huge dew point depression that we're going to have to overcome before the precipitation starts. That gives us a couple of opportunities. One, if we can begin evaporating liquid precipitation, if it is liquid, in fact, fall into this, that's going to bring this temperature curve off to the right and begin to saturate us up. So we're going to be evaporating precipitation to this dry layer. It'll cool us off. If we go ahead, we don't have to change our location. If we go ahead, there's the time scroll just a little bit. Let's say 3 hours, maybe it's the smallest increment. Bang, in 3 hours, we go from 7 o'clock in the morning to 10 o'clock. Here is the 0-degree isotherm. All right, we're saturated, and we're cold enough for frozen precipitation through this entire depth. So this is going to occur pretty quickly. Let's the first flakes or liquid precipitation begins to fall. At least in this model forecast, things are going to rapidly consolidate to this liquid precipitation. Again, we don't want to just look at one model. Let's look at the GFS at this time. I'll look at the GFS FU3. This is a little bit warmer. Still has us at 39. Let's look at the GFS FU3.
It just hasn't adjusted.
Yeah,
It's still got adjustment to go.
Yeah. You can see the GFS FU3 is also gets us down below freezing. I think at the surface, we're just a hair above that. Best precip type, at least by the algorithm they use here, which I can't speak to, is snow. Let's go to the GFS. Even with that warm layer, snow, and certainly for the NAM, is also going to be snow. So we're looking at snow. All right, so this is early in this, it's late in the spring season, or not spring season, or early spring, late in April. Let's go ahead another 3 hours. Must be getting warmer. Nope, we're stuck at 32. Saturated for this entire depth of the column again. Most likely profile is precipitation type is snow. Nice varying profile on the surface. You think very strong warm advection, geostrophic warm advection, but we have such large, incredible ascent that's occurring. We no longer have the evaporation cooling there. This is just a simple vertical advection of isotropes. It's just getting cold. The air parcel trajectories are steeper than the isotropes are lifting them, ripping them out of the ground. as the snowfall cools everything off. So this is snow. We go ahead another 3 hours in this forecast. Down to 31, and this is at 21. This is 4 in the afternoon, 31 degrees and late April. Still cold. It's still a fairly strong warm convection, best precipitation of snow. Let's look at a couple cross sections. This is when we go to tropical tidbits. Let's do this.
That's the one frontal zone too.
Right, we're just out here, we're right through the frontal zone.
Yeah.
We'll look at some of the structure of this forecast models. We'll stick with the NAM for now. Let's go. Yeah, stand free pop card, you can do that. We'll go immediately to 24 hours, at least initially. We can step through just to get a sense of the evolution of this. So this is actually another version of the NAM, 3 kilometers close to the 12 that we're looking at. You're in 452 next semester. Do not turn in analysis that looks like this. Surface pressure. I don't know if you have the time to do analysis that looks like this. But let's step ahead. We can go every hour here, so that'll be kind of neat. Let's go to, so we step forward, see the precip arriving, rapidly changing over to snow. We can do a cross section. At this point, I want to just do let's do, what's your idea? Would you want to go normal in the front?
Yeah, I like to go as normal as I can. Yeah, and like make it long so you get a nice aspect.
Yeah, you normal.
Yeah, need normal. Yeah, that's right.
Okay, so for maybe the tip of the finger, where my hand is in.
Yeah, that's
kind of not a cross section, so I can get hold of control now. Okay. Sounding about control. It's control. Let go of that. Okay, so this is going to be a plot of frontogenesis, theta, E, and omega. You submit that.
Oh, yeah.
Okay, so frontogenesis is given in the pink line. So frontogenesis is a measure of the time rate of change of the magnitude of the potential temperature gradient. The shaded regions right here are omega, so again, negative values are going to be upward vertical motion. We're at about 43 degrees north, so we're going to be in the zone below where we have significant upward motion. But you can see the frontogenesis, just as John was indicating with Biz 5D, you're going to have air parcels that are undergoing frontogenesis here on the warm side of these baroclinic zones where you see the upward motion, you get this transverse circulation, warm air rising, cold air sinking. I think also as the front strengthens, that's also going to affect any colder temperature, colder air going north, the lower troposphere, southward. That's also going to contribute to some of the cooling at a very thin layer near the surface. But here's our vertical motion pattern at this point. You can probably be okay by going ahead. I don't think the orientation is going to change too much. Just go ahead over time, and you can see the frontogenesis just strengthens, so just driving these air parcels upward along the baroclinic zone. You can see the theta E contours are also similarly tilted. I don't see in here much evidence of, I guess there's a little bit of instability here. These are theta E, but I don't know if they're saturated in this location.
Out ahead of the front, closer to B, there's a region of convective instability, but you don't know if it's really going to be.
You're gonna get involved into the
conditions.
Right.
Potential or
Potential, yeah, for the layer. So if we can, what I want to do, we can change, scroll down just a little bit, I think we can change what's actually plotted here. Let's look at the relative humidity omega, get a sense of there's that dry air that's to the north, and having that continually being affected in the lower troposphere is probably good for us because it keeps things, the potential for an evaporative cooling to occur, but you can see really huge region of moisture in a region where we have a frontogenesis. This can be really tight precipitation. My biggest concern here is that the vertical motion that we saw with John's earlier GFS forecast and with this event are that I'm wondering if the precipitation is going to be more confined, the heaviest just to our south. We have such steep isotropes. I wonder if we're just going to be able to, how far northward this moisture transport is going to be in the frontogenic circulation to give us snow. So, or keep us snow. It's going to be snow definitely, but give us significant amounts. Let's go out of this. So just go back, close this up. I want to get a cleaner map, so let's scroll down a little bit, or scroll up, sorry, and let's go to the 12 kilometer now. It looks a little bit more cartoonish, but it's smoother. And let's go out to 30 hours. So tomorrow around 1 o'clock, You can see our surface cyclone still tracking along. Go to 36 hours, so this is tomorrow evening. 99, still in the snow. Beautiful track, 999. There's the snow there, and we'll take a moment and just look at that.
Yeah, I think we should.
Go to 33 hours, so this will be 10 o'clock at night. I think by then everything's wound down for us. 33. Oh, sorry, I'm going backwards in time. I want to see it longer. 39, thanks. Yeah, so it's just all but southeastern Wisconsin, and the cyclone's beginning to weaken. And we'll see the upper trough doesn't really maintain its integrity as well as we probably would have liked. I think that might have something to do with the phasing between these, but time is short. Let's go back to pivotal. It's what everyone's been waiting for. What's that?
If it's a little quicker clear out, we might have that perfect situation which you have a brand new snow in late April and a little bit of the setting sun on top. Usually I don't like that one, but in April I don't like it.
So this is a 24-hour forecast of snowfall. This is 10-to-1 ratio. Don't expect it to be that, but I know the Kuchera technique, which uses the maximum temperature from the surface part of the Mars, kind of goofy. So just and this is more fun. The end of the semester. Let's keep it these amounts high. So we look at this, but before we even go any further, let's just go to the zoom in. It's really look at these amounts, and we'll get to the final weather service forecast. So this is at 0Z. Oh, hold on, it's 12.6. I don't think we're done yet, right? It's probably still snowing at this point.
It's not over yet.
12.6. So this is in the NAM. It's over. It's done. But how much of this is actually expected to be on the ground? Because at least the snow depth will account for some of the melting. Yeah, about 5.5 inches, which isn't too bad.
Still unbelievable.
Big gradient. So this is keeping the heaviest snow just north of us. So to the extent that I was hoping that things would be, anticipate things further south, maybe this isn't such a bad spot to be in. Let's look at the, go back to the totals, because that's always more fun than the reality. And then go to the GFS. GFS actually does have heavier amounts just to our south, 8.7 along the border, 6.8 for us, with a snow depth of only 2.8. Not so bad, it's still, again, what you would expect in late April. And then GFS FD3, hold on, at 12.3. So a couple of these models do have a heavier band of snow just to our south. The ECWF is a little bit just to the south of us. I mean, this is, again, this was, you know, we always say if we're colder, if this were 3 months earlier, we would be, I would be looking for provisions and stocking up.
It's what the latest ECWF has basically that exact same track.
Is it the 0 or the 12?
The 12
Okay.
just came in.
What's it give for Madison?
The total start, it's only out until 18Z on Saturday, so I'll let you know by the end of the day.
Okay, yeah, we're gonna be wrapping up shortly, as we abbreviate this. But yeah, so the Weather Service is going 5 to 10 inches of snow. I think the big factors to watch are gonna be just where this band ultimately sets up, the heavy snow band, if you go back to the actual forecast map, surface map. And go back to, let's say, midday tomorrow, 30 hours. You know, as this eventually sets up, I mean, if, in fact, we can look at one last thing, the, sorry, beat 850, the printer genesis, and maybe you want to go to 925. Sure, lay down temperature. We've got a really nice confluent flow right along these isotopes, so just packing them together. And so the strongest photogenesis at the surface you see is going to be well to our south. If we go to 850 at the same time, I mean, this isn't the height of the storm for us yet. You can see that gets a little bit further to the north. It's closer to us with this broad confluence, so it's, you know, just right along there, just north of the border. So this is where the models are forecasting that have, you know, this heavy band is set up. But in any of these situations, you really have to wait until that tomorrow afternoon, early afternoon, to see where this sets up. If we go ahead just 3 hours, sorry, the mid-afternoon, I think that's when everything's really going to be going pretty strong. Really nice frontogenesis in the lower troposphere, just south of us. This is going to be a really good place to be at this point. And it really just, the track of the surface cyclone, we just have for the 850 cyclone, it's nearly perfect for a decent snow event, or along northern Illinois. And we're cold enough at this time of the year to have frozen precipitation. Where it's being created all the way down to the surface. I think that's just absolutely incredible.
Stunning.
Michael, go ahead. I was just gonna ask, how quickly was the snow depth diminished to 0?
Oh, okay.
We don't
Before we get to
know that part.
Why do you want to end this whole thing? Let's enjoy one other aspect of this surface, there's 2 meter temperatures. That's the other thing I want to talk about. So snow is over, this is 3Z on Sunday, so it's early Sunday morning when the snow is still out here. They have us at 32, we're going to compare that with some other forecasts, but 32, we'll go ahead to 6 hours later, down to 25, and then by Sunday morning, actually, so they went down to 24.
Yeah.
GFS, at this point, 27 and 12Z, what's the, just a little bit before that? 45 miles. So maybe mid-20s is coldest in Danam. I think it's the coldest of all of these. 24, we go ahead.
It's gonna be 21.
22. So with fresh snow cover, we have to look to see if we've actually cleared out. I don't know if we can we do a sounding over this? At least see what the. Probably cleared out.
Yeah, I would guess.
Little clouds off to the southeast, but we're probably gonna be, no precip at this point, but we're certainly gonna be dry enough in the lower slopes, we're gonna be probably radiating like crazy. It's gonna be cold on Sunday morning. So it's gonna be fresh vegetation outside, bring it in. So the question was, how quickly do we go to 0? Let's get rid of this. Go to snow depth. Here, it's Sunday morning. Could be around for a while. Come in on Monday, so it's snowing around.
You might be, huh?
What's this? New snow. Fresh snow.
Yeah, there'll be snow on the ground on Monday morning.
Monday evening still.
Monday evening.
Man,
GFS, it's all over the north. And FD3. Yeah, I feel a little bit lingering down there. I don't think that's new. So that's it for today. So it looks like we're gonna have snow developing.
Yep.
Early, sometime tomorrow, by mid-morning, it should be snowing. It looks like most of the day we'll actually see snowfall. Temperatures dropping into the low to maybe mid-30s at worst by afternoon, and then dropping to the low 30s with significant accumulations probably in the late afternoon. So I think, the best chance of really looking impressive is probably from 3 to 7 tomorrow.
Yeah.
They're really impressive, those snowfall rates.
How much of a role do you think West Michigan's going to play on this? Because it seems like the site is perfect for bringing a lot of moisture into something.
I don't know. I don't get a sense it's going to play that big a role. I think what the moisture is bringing with it is largely in things from the south, the trajectories are
Yeah,
more
and the
warm
cyclone,
sector.
cyclone's weak too, but it might be enough to make the heavy snow band just to our south. If you think about the flow of air on the northern portion of that storm, maybe it does actually take a little bit of extra water off of Lake Michigan and drop it on top of that band. I don't know. It's a good question.
Yeah, I haven't looked at that carefully, but yeah, good question. But, yeah, I think tomorrow's going to be, that's a pretty neat looking day with the snow piling up.
Yeah.
Right.
who was it that said, I'm not colorblind, I'm color disinterested? Was that you? Matt Lane, one of our former students, said he's laughing pretty hard in his office right now.
Oh, yeah.
One last thing, since we are here, and I like to always look ahead to next weekend. We postponed our events. Next weekend, no snow, that's good. All right. At least yet. And precip type and rate,
Hey,
that was warmer than earlier
551 thickness.
for the afternoon. Go for you. This is for next weekend. It's not this coming weekend, but next weekend's also maybe a few showers, but it looks.
That's late in the day. That's really
Yeah.
late in the day.
Yeah, it's 7 o'clock, so yeah, that's late. So, it'd be decent.
All right, that's great.
Well, thank you, John, for a really great
Thank you.
tour, and thanks, Pete, and thank you all for coming, and I guess next week will probably be our last weather watch.
Unless it snows after May 3rd.
Right. All right, yeah, thanks. One.
Yeah.
You want to just roll with the evening, so-
I think we should, yeah. We can take a quick look if it's.